Dear participants, I am Feyza, Research Assistant at Gazi University Department of Architecture. Today I will present to you the research titled Machine Learning in Building Energy Performance Assessment, a review that we prepared with Associate Professor Semra Arslan Selçuk. All over the world, climate change caused by the environmental pollution emerged due to the increasing need for energy, and the use of fossil fuels increases concerns about the sustainability of the environment. When the final energy consumption is analyzed according to the sectors at the global level, it is seen that the share of buildings in this consumption is approximately one-third. In addition to that, buildings are also responsible for 40% of the direct and indirect carbon dioxide emissions. The fact that the building industry has such a large share in global energy consumption has led to the consideration of the destructive effects of buildings on the natural environment. It is aimed to contribute to the solution of these problems with energy efficient and performance-based designs. Developing artificial intelligence technologies and specifically machine learning techniques have started to play an increasingly important role in performance assessment. The energy systems of buildings are quite complex as they are affected by many different factors. For this reason, it becomes very difficult to accurately and quickly estimate the energy performance consumption of buildings. Artificial intelligence and machine learning systems can be very effective in solving complex problems. Especially in recent years, many machine learning based methods have been used by researchers for the assessment of building energy performance. In this context, the purpose of this study is to present a review on the use of machine learning techniques in building energy performance assessment. For this purpose, a bibliometric analysis is conducted to determine the relationship between the building energy performance and machine learning. Web of Science database has been chosen as a database to be researched. The research is carried out between 2010 and 2021 in order to examine the trends in the related field in the last years regarding the keywords building energy and machine learning. The research includes only articles. In order to analyze the information obtained as a result of the research, RStudio and BiblioShiny software package are used together. As a result of the research, a total of 142 articles with the specified qualities are found between 2010 and 2021. As can be seen from Figure 1, research in the related field have intensified and the number of articles has increased in recent years. In 2020, a total of 50 articles with the specified qualities are published and the highest number is reached. While a total of 33 countries contributed to the analysis of the articles examined, only 3 countries published 10 or more. This shows that the research field is not studied adequately in many countries. We can say that economically and technologically strongly countries are more active in this field. Some countries' publications appear only as single country publications. This shows that these countries do not have any cooperation with other countries. As can be seen from Figure 3, where the top 20 most productive authors are shown, the authors' publications take place especially in 2016 and beyond. The most productive period is 2018 and beyond. Figure 4 shows the relationship between the most co-occurred keywords, the top 10 productive authors, and the sources. Almost all authors have published in the Applied Energy Journal. While the most commonly used keyword is machine learning, the only author who did not use the machine learning used the deep learning keyword. All studies are directly related to the building energy. As can be seen from Figure 5, where the most cited documents are given, 2 of the authors of the 5 most cited articles are among the most productive authors. As can be seen from the slide, in the first 5 most cited articles, different machine learning techniques are used on different building types for different type of energy consumption. When the keywords in the studies are analyzed, it is seen that the most preferred among the authors is machine learning. In general, it is seen that studies generally focus on heating, cooling, electricity, and general building energy consumption. Machine learning terms that stand out in the field of the building energy performance are artificial neural network, support vector machine, support vector regression, recurrent neural network, deep learning, and reinforcement learning. For more detailed and systematic information acquisition, all articles are examined and a Sankey diagram is prepared regarding the years of studies. The building types used in the studies, the machine learning method and in which field it is used. As can be seen from the diagram, office buildings and residential buildings have been studied more intensely than other building types. It has been observed that the studies on mixed-use buildings, which are frequently used design today, are limited. The share of mixed-use buildings in these studies is approximately 1%. There are studies on different subjects from determining energy consumption to trying to increase energy efficiency with various parameters and occupant behavior related energy performance. The most common usage areas are general energy consumption, electricity load consumption, heating load consumption, cooling load consumption. While heating load consumption has been studied more in residential buildings, the cooling load consumption studied in office buildings. Apart from these, the subjects that are rarely studied can be listed as building climate zoning for energy efficiency, smart energy systems, building energy labeling, embodied energy life cycle assessment, and life cycle cost. The prominent machine learning methods used in the review articles are artificial neural network, random forest, support vector regression, support vector machine, and linear regression. It is seen that some methods are specialized according to the usage areas. Generally, many methods have been evaluated comparatively in examined articles. This has supported the selection of the most suitable method for the usage areas. However, since the methods compared in general are similar in different articles, it is thought that comparing other methods in a mixed way may result in different potentials. To sum up, it has been observed that machine learning methods are frequently used in building energy, especially in recent years. It is thought that the increase in the number of countries contributing to the studies and the number of collaborations will be effective in energy performance improvements. Mixed-use buildings, which are used intensely today, have been studied not much in the research. Both the machine learning methods used in their usage areas in the studies are concentrated on some topics. It is thought that energy efficiency in buildings can be increased holistically as less studied subjects are evaluated more in research. Generally, machine learning methods have been evaluated comparatively in most studies. However, generally, the same methods have often been compared with each other. It is thought that the less studied methods can also be experienced with different areas, which may create various potentials. When the results of the examined articles are evaluated, it has been determined that machine learning is a very effective method in building energy performance assessment. It is clear that possible developments in this area will contribute positively to the global energy consumption and greenhouse gas emissions. Thank you very much for listening.